Okay, so welcome to day 2 of volume. Today we're going to be actually talking about similar solids. So similar is 3-dimensional shapes. So first things first, I want you guys to pull out a scratch piece of paper, something to do notes on. I'm going to go through some examples and kind of go through what this is going to be asking. So when we're talking about similar shapes, these are shapes that are proportional to each other, right? We've talked about this a little bit this year, but basically anything that's proportional, like all the sides would have the same dilation factor, right? Or what we call the scale factor. So usually we've done this a lot with like transformations. Remember when we dilated stuff? We talked about it with triangles a little bit. But today we're going to be basically given 2 shapes, and we're going to be asked to figure out if the 2 are similar. So that means that each side is going to have the same proportional length to each other. And that proportional length would be, or that proportion would be what we call the scale factor. Okay? So how you find the scale factor is you basically take the same 2 measurements on each shape and divide them. So usually we have some kind of like, this was original, this was the new one, or whatever. So today, just to be consistent, we're going to go take the factor from the left side, divide it by the same one on the right side. So first thing we're going to check is we're going to check to see if it is in fact similar. So to see if they're similar, that means that when I divide each measurement, I should get the same scale factor for each one. If I get the same thing, that means these are going to be similar. And if they are similar, I'm going to say what that scale factor is. So I need a calculator for this, so I'm going to start with the radius. So I'm going to take the radius of the one on the left, which is 50, divided by the one on the right, which is 30. So 50 divided by 30 is 1.6 repeating, or as a fraction, which is how we write scale factors. So you're going to need to convert it to a fraction again to convert it. I mean, if you have a calculator that has a fraction button, you would, or a fraction decimal button, click that. Otherwise, I'm sure there's lots of stuff you could Google a fraction, a decimal converter or something like that. Okay? But this is 5/3. So the scale factor between the radiuses are 5/3. Now, in order to be similar, that means the height would also have to have a scale factor of 5/3. So let's try it. 200 divided by 120 is going to be 5/3. So to answer the question, yes, they are similar, and the scale factor would be 5/3. Okay, not too tough, right? Let's try another one. So let's look at number 2. So this one gives me a radius, but we've got to be very careful because the other one, this 18, is that the radius? No, that's a diameter. So the first thing we're going to do is I'm going to convert that diameter to a radius. So 18 divided by 2 is 9. Okay? So again, from the left, I'm going to do 72 divided by the radius on the right, which is 9, which is 8. So scale factor of 8. Let's try the length here. So 192 divided by 48 is 4. They are not the same, which means this is not the same proportional relationship. These are actually different cones. So no, these are not similar. That's all I got to write. Yes or no. And then if it is yes, you write the scale factor. So let's try another one. Let's try the pyramid here. So 24 divided by 48 for the length is 0.5. Okay? Let's try the width. 12 divided by 24 is 0.5. Great. Let's try the height. 28 divided by 56 is also 0.5. But again, we want that as a fraction. So 1/2 was our scale factor. They were all the same. So yes, these are similar. Scale factor would be 1/2. Okay? Try one more. Let's do a sphere. So sphere, again, it gives me a radius on this side and a diameter on this side. So I want them both to be the same, so I'm just going to change this diameter to a radius, so that would be 5. So I'm going to do 5 divided by 25 is 0.2. There is only one measurement on spheres, and I'll give you a little hint here. Basically, all spheres are similar. Crazy, right? Because they're all going to have like that same like dimensions. There's only the one measurement in all spheres, right? The radius. So they're all going to be similar. So the trick here with spheres is we know they're going to be similar, but we need to still figure out the scale factor. So 0.2 is 1 over 5. So 1 over 5 would be your scale factor. And that's all you're going to be doing.